Everyone, I am Haley Prajapati, and in this video I'll be talking about face recognition system. This is the content of the presentation. Identified real-life problem to be addressed using artificial intelligence. In this video, we'll be talking about face recognition system, which is a technology capable of matching the human face from a digital image or a video frame against database of faces. And the problem is that nowadays security plays an important role in day-to-day life. So the use of internet in human life has become the day-to-day activity. And with the use of internet, automatic devices has increased. So all transactions need to be secured. And hence, I have introduced this system to be applied in many fields like security issues, authenticate users, etc. How a dataset will be used. The dataset in this system is generated automatically with a unique ID of the user. When the system gets permission from the user, it captures the image of the human beings and stores it in a separate folder. The face dataset provides a diverse set of images containing human faces. A face dataset may include lighting conditions, poses, emotions, and other factors like age, gender of the people in the image. The datasets are commonly used for face recognition, and yeah, how a dataset will be used. This is the continuation. It can be used as a building block or to track faces in an image and a video. It will analyze the facial expression, it will detect the facial signs, which can be used in medical diagnosis, face recognition, and many more. This is actually a dataset. Factors that I considered before selecting that dataset. Well, firstly, in the face data, first is that each picture is centered on a single face and every picture is encoded in RGB. The original images of the sizes are like 250 times 250, and the dataset contains 1,680 directories, each representing a celebrity. And for extracted faces, the faces are extracted from the original image and they're encoded in RGB, and the size of the image is 128. Important features in my dataset. Well, the first feature is that the image is captured. Then in the second, the eye locations are determined. Then the third image is converted to a gray scale and it is cropped. And the fourth image is that it is converted to a template used by the search engines. And the fifth is that it is searched and merged using an algorithm to compare the other templates, to compare the template to the other templates on a file. And the duplicate license are actually investigated for fraud. The Bayes theorem. The probability of two events A and B happening, A into A intersection B is the probability of A, P into A times the probability of B, given that A has occurred. And that's the equation number 1. And then on the other hand, the probability of A and B is equal to the probability of B times the probability of A given B. That's the second equation. Then by equating the two equations, first and 2, we get the third equation. Thus, the last equation is known as the Bayes theorem. Naïve's Bayes. All modern probabilistic systems are based on the use of Naïve's Bayes rule. which is by the product rule, and the commutative of the conjunction. When you equate those two equations, like the right hand sides, when you equate them, you get the Bayes rule. Then for more generalized case, you use multivariables x and y to get a normalized Bayes rule. Bayesian networks. Every entry in the full joint probability distribution can be calculated from the information in this network. This network is a complete and redundant representation of the domain. In this network, we can actually exchange the accuracy with complexity, and the generic entry in the joint distribution is the probability of the conjunction of a particular assignment to each variable. This is the construction of the Bayes network. We can rewrite an entry in a joint distribution using the product rule as that first equation. Then we repeat the same process, reducing each conjectivity probability to a conditional probability and a smaller conjectivity. We end up with a bigger product. Then this identity holds true for any set of random variables, and it is called the chain rule. The specification of the joint distribution is thus equivalent to the general assertion for every variable xi in the network. The difference between Bayes' theorem and Naïve's Bayes is that in Bayes' theorem, the theorem does not assume conditional independence, while Naïve's Bayes, it assumes conditional independence. Then in the Bayes' theorem, there is a mathematical formula used to determine the conditional probability of the events, while Naïve's Bayes is a technique which is very effective on a large range of complex problems. Then Bayes' theorem, it can be applied in other real-life applications like internet marketing, to profile visitors to a website, in decision analysis and decision trees. So hence it's not only a mathematical formula. And Naïve's Bayes, it can be used to make real-life predictions as it handles both continuous and discrete data. The difference between Naïve Bayes and Bayes networks. Bayes networks is a model relationship between features in a general way, while Naïve Bayes is actually a simple model where all the features are mutually independent. That is the graph representing Naïve's Bayes error and Bayes error. Here in this graph, we can see that there are some points below the diagonal line representing the Naïve Bayes, which performs better than the Bayesian network on the datasets, and also some other points on the digital line representing the reverse on some of other datasets. This is the references where I did most of my research from. Thank you.